Hello everyone, welcome to this video. This is part 4 for classical mechanics of the semester 1 for physics honors, and this is also a benefit for others examination also. In this video, we want to discuss about the system of particle. Already 3 classes are done and the link is given in the description box. If you want, you can watch them. Okay, so let's start. This is the syllabus for University of Calcutta Physics first semester. In the previous 3 lecture, we already covered up this portion, that is the A part already covered in the previous 3 lecture with the problem solution. And in this lecture, we want to discuss about this portion, that is the dynamic of system of particle. This is the difficulty of solving of the equation of motion for system of particle, Newton third law, external internal force, momentum and angular momentum of a system, torque acting on a system, conservation linear angular momentum, center of mass and its property, two body problem. Up to that point we want to cover up in this lecture. Okay, so and the upcoming lecture we will cover the next one. So let's start. This is the total syllabus for the mechanics part, and now comes into the first point, which says that the difficulty to solve the equation of motion of a system of particles. System of particles means there is a large number of particles. This is a body, there is a various point masses are associated. If there is one point mass, you can write the equation of motion like that. The equation of motion will be mass into acceleration, that is d2r dt square, equal to force for the single particle. You can write easily this equation of motion, but there is a large number of particles. So for each particle there is a differential equation for say this is a particle 1. So for particle 1 the mass and this is acceleration, this can be written also in this form. This a can be written as the double derivative of the position vector, right? This will be equal to the total force. This F12 is the force on particle 1 due to particle 2. So on that particle there is a force due to particle 2, due to particle 3, due to particle 4 and so on, particle n, right? So these are the force for the internal part. This is the force on particle 1 due to 1, force on particle 2 due to 3, force on particle 1 due to 4 and force of the particle 1 due to nth particle, right? So this is total are the internal force, and these are the external force on particle 1. This is the external force on particle 1. Similarly, if you wants to write down the equation of motion for the particle 2, for particle 2 you can similarly you can write this is the particle force on particle 2 due to 1, force on particle 2 due to 3, force on particle 2 due to 4, force on particle 2 due to nth particle, right? So these are the internal force and this is the external force exerted on the particle 2. In this way you can write the n equation of motion like that. This is the equation of motion of nth particle. This is the nth particle, right? So there is a 3n number of second order differential equation, because in this R1 there is 3 component x1, y1, z1. So in this equation you will get 3 differential equation, and so in this nth n number of equation you will get 3n number of second order differential equation. So to solve this 3n number of second order differential equation is very clumsy, right? So this is not done easily, this is very difficult. So this is the difficulty to solve this equation of motion of system of particle. I think you are understand my point. These are 3n number of differential equation solution can be obtained is not very easy. This is a very difficult problem. So to solve this type of question, what will be the our approach? This is the target of this lecture, right? So first you just remember your previous thing, that is the Newton third law. You know, if a body A exerted a force of another body B, there is two bodies. Suppose there is two body. This is body A, this is body B. So if exerted to body A some force, then B also exerted the same force with the opposite direction, right? This is a Newton third law. But this law is not valid as everywhere, because if sun moved by a distance, if sun is moved by a distance, then the action and reaction will be earth will not taken in the new value until the signal reach the earth. That means if this sun displaced somewhere, you know this is moving in the Milky Way. So if sun is moved in displaced in some point, then what happen? The force will be gravitational force will change, but this information reach Earth after a certain time. They need to some time to get the information displacement of the sun. So there is a mismatch. This law is valid, okay, but in that case when this there is a distance matter or the relativity, I think I want to show that is the gravitational wave. You know this is already discovered, gravitational wave. So there is a time delay between the information getting from the sun to earth, that is displaced. So there is a mismatch at that time. The action reaction is not equals always, right? So in that situation, when these are the instantaneous progression, when these are they are situated in at that moment, if we take at this moment, then the are equal and opposite, right? So if you want to find out total sum of the previous differential equation, if you just add this portion, then you can say these are cancel out because these are the equal and opposite. Similarly, this total internal will be 0, only the external are exist, right? So the sum of these external force are taken as the total external force. Okay, so you can see there is no dependency on the internal interaction. So in this body there is a internal interaction variance, but as a whole their total interaction will be 0, right? So you can see this, like that. Now comes into the external and internal force. Internal force means the force within the body. The particle are within the body. The force within these two body is internal force, and the external force is the due to external agent, right? So the force exerted on the system of particle by the external effect is known as external force. For example, applied force, some applied force, normal force. Suppose there is a body. Suppose this is a body and the body is placed here. So this is mg along and this reaction force, right? So this is reaction force, normal force, tension force. These are the friction force are the external force. And for in case of internal force, the gravitational force, magnetic force, electric force, spring force, these are the internal force. There is another classification of force as conservative force, non-conservative force. We will be discussed later in detail. And contact and non-contact force. Contact force mean the force which are contact with the body. If there is a body and if you sorry, if you force with contact, then is a contact force, and the non-contact force, that means there is no contact. Because if you take a north pole and south pole, if you placed a iron, this is attracted north pole, not this is a magnet. If suppose this is a magnet north south and there is a iron, so this will be attractive. These are not contact but also is attracted, right? So this is the contact force and non-contact force. This is the contact force is the contact with body, and non-contact is not contact with body, right? Next is important is momentum, angular momentum of a system. This equation taken from this last expression, that is the this expression this is the equation of motion of the system of particle, right? These are taken as external. So this equation right here. Now if acceleration, you know acceleration is mass into acceleration is nothing but dp dt, right? Mass into acceleration. What is the mass into acceleration? Mass into acceleration, mass into this is dv dt. If mass is constant, you can written as mv dt. mv is nothing but dp, so this is dp dt. Clear? So we can write this say m1 a1 can be this m1 a1, this m1 a1 can be written as dp1 dp2, this and that, like that, right? So if you just common ddt, you can write this if we add this p1 p2 p3, p1 is the linear momentum of particle 1, this is particle 2, this is particle n. So dp dt will be like that, where p is the summation of the all linear momentum. Okay, so similarly you can say the angular momentum of this system. Angular momentum is the summation of the all angular momentum of each particle. This can be written in the summation form, and angular momentum is depend on linear momentum. With this, L is r cross p, so p can be written as r cross m, and This is the relation. And comes into the torque acting on the system. Torque is known as the R cross F. You know, R cross F is the torque. So F as a two part, external part, internal part. So external part, internal part can be written in the Fij. Internal is the particle, that's mean this ith particle, this is jth particle, this is ith particle, this is jth particle. So in between there is a interaction Fij, right? So summation of that will be 0, because the Ri and Fij are in the same direction. Ri and Fij along the same direction, that is the cross product will be 0, right? So Ri cross Fij will be 0, must be 0, right? Sorry, this must be 0. Clear? Next, so this will be 0. So you can write here, this can be written also dp dt. So the dt of like that. So this r cross p will be L. So this is another form of torque is the dl dt. We will be use that in later. And now comes into the conservation of linear momentum. For conservation of linear momentum, if there is a no external force, the external force will be 0, and you can see here this dp dt will be external force. So if this will be 0, then p will be constant. Similarly, if torque will be 0, then L will be constant. This is the conservation of linear momentum. When the force will be 0, the momentum will be conserved of the system. If there is no force, this is of a particle, there is no force. If external force will be 0, then p will be constant. P is the linear momentum will be constant. If this body and torque will be net torque will be 0, then L will be conserved, right? So in case of linear momentum will be 0, linear momentum constant, force will must be 0, and torque 0 means angular momentum conserved. Clear? Next is the concept of center of mass. Think, we understand the problem of the system of particle. To solve the differential equation of a system of particle is difficult, right? So to solve this type of problem, we introduce a concept of the center of mass. What do you mean by center of mass? In basic, you can say that uh, if this is a body, if there is a body, if there is a body, and if you apply any force along the center of mass, if this is a center of mass, sorry, suppose this is a center of mass, and if you apply the force along the center of mass, then no rotational motion, no rotational motion. This is the basic criteria for the center of mass. No rotational motion. If we apply force along the center of mass, then there is no rotational motion. Okay, and this can be also says in other term, that is the mass. That is the linear moment, which is also called the moment of mass, also 0. Moment of mass means summation mi ri. That means, oh right, here written here. So summation mi ri will be 0. That means this is the center of mass position. This is called as the center of mass. This is the center of mass position. Okay. So the capital Ri is the position of the ith particle with respect to center of mass. Position of the ith particle with respect to center of mass is the Ri. So summation of this, that means the this is called moment of mass. Moment of mass with respect to center of mass of a body will be 0. That's why the no rotational motion happen here, right? So if you write Ri is this equation, Ri will be nothing but this small Ri vector minus RCM vector, right? So this is the formation of this Ri. This is the basic criteria for the center of mass. This is the basic criteria for the center of mass. Okay, so if you put this value, you will get this equation, and then separate out, and just RCM is a constant. This is not vary. This is a constant position. So this will can taken out outside from the summation, and this is the summation of total mass point. This is the mi is the one mass point, and summation of mi will be total mass of this body. M will be total mass of this body. So you can write as this total mass. So you can get the position of the center of mass. Position of the center of mass will be 1 by n summation mi ri. This is the formula of the center of mass. So this center of mass can be calculated for in case of two type. This is for discrete point mass. Discrete point mass means the point mass somewhere here. This is a m1, somewhere here m2, m3, and so on, m4. These are not continuous. And for continuous, no, that means consider a line, or you consider a plate, or you consider a volume, like that. This is the continuous. This is the continuous mass. Okay. For discrete you take the summation, and for continuous you take the integration. This is the basic difference between discrete and continuous. For discrete point you need to take the summation, and for continuous point you need to take the integration, right? So you can get the center of mass position. This is x, y, z, and if you wants to return in r, so r will be I cap x, j cap y, k cap z, right? So you need to remember, for discrete there are need to in summation, and for continuous you need to write in integration form. Now we take the RCM equal to, like that, we already obtained this equation in here. So RCM equal 1 by m summation mi ri, right? Now if you summation mi ri, oh, this is ri summation mi, right. So if you derivative with respect to t, you will be get the velocity. So if you derivative with respect to t, this is vcm, and if you just derivative with respect to, you will get dri dt, because mi is the constant, so you will get vi. Mi vi is pi. So p summation of pi is written capital sorry, total p. This is the total p. We already written somewhere earlier. You, I think, remember the previous one. This momentum is written as the summation of this p1, p2, p3. Right. P1, p2, p3 are written in the p. So you can also here written this formulation, that is summation of pi equals to p. So velocity of center of mass will be p by m. The this p is the total momentum. This is the momentum of system. Momentum of system, right? M is the mass of system. Mass of system, and VCM, you know, the velocity of center of mass. Velocity of center of mass. Clear? Next, if you wants to find out the acceleration, if you wants to find out the if you wants to find out the acceleration, if you wants to find out the acceleration, if you take the again derivative with respect to time, then you will be get this like of equation, and dp dt will be f external. So the f external will be m into d2 rcm by dt square. So you can see here the m external will be written in a single second order differential equation, whereas in this there is 3n number of differential equation. These are the difficulty, you know, remember that there is 3n number of second order differential equation. To solve this equation is very difficult. That's why we reduce this into the center of mass equation. By reducing this equation using center of mass, you can see here this equation is very easy. This is only one second order differential equation, so you can solve this equation easily, right? If you wants to know about the differential equation solution, you also can refer you can also refer to the there is a playlist in our channel. You can also watch the differential equation here. Okay, so comes into the angular momentum. Angular momentum r equals to r cross p, and this r can be written as rcm plus, this is the center of mass, this point is center of mass, this point is center of mass. So rcm plus ri cross pi, and just separate out these two, and this portion you can see this is the total momentum. So this is angular momentum of center of mass. This is the angular momentum of center of mass, right? And this is the angular momentum of the particle with respect to center of mass, because this position taken from the, this radius is taken from the center of mass. So the This is the angular momentum. um, this is the angular momentum of the particle with respect to center of mass, and this is the angular momentum of the system of particle. So now we can write the angular momentum of system particle with respect to center of mass and the angular momentum of the particle with respect to center of mass. This is the angular momentum of the center of mass with respect to origin, and this is the angular momentum of the particle with respect to center of mass. Okay. Similarly, you can write in case of kinetic energy, this mv square, and this is not by vi dot 2 if you wants to in vector terms. Since these are is written in here, the ri vector equals to rcm plus capital ri vector. So if you derivative, you will be get vi vector is equals to vcm vector with respect to time. So you will be get vi vector. This is small v and this is capital V. Okay, capital V is the position velocity of the particle with respect to center of mass. Small v is the particle of the velocity with respect to origin, and this is the velocity of center of mass with respect to origin. Okay, just dot product, you will be get this term, that term, and this term. This will be gives you 0 because there is a summation mi ri will be 0. This is the definition of the center of mass. Clear? This is the definition of the center of mass. The mass moment will be 0, moment of mass will be 0, right? So you can write the total kinetic energy of the system will be half m is, this is the kinetic energy of center of mass, and this part is the kinetic energy of the particle with respect to center of mass. This is with respect to origin, and this is the kinetic energy with respect to origin, right? So the it comes into the two body problem. This is a special case for the many body problem, right? So for a system of particle, this is the two body problem. This is a special case. Suppose this is two mass m1 and m2 situated at the r1 and r2, and this is the origin. This position you can say this is the origin. With respect to origin, this is the center of mass position, this is the center of mass position, and these two are particle. Now, if you want to write down the equation of motion of this particle for m1, this is the m1 into acceleration equals to force on particle 1 due to 2, force on particle 1 due to 2, and this is the external force. So this is internal force, this is external force. Similarly, in case of m2, this can be written as m2 into acceleration of particle 2, and this is the force on 2 due to 1, and this is force on 2. And if you multiply 1 by m2 and multiply 2 by m1, then just subtract it, you will be get this equation. Just multiply into just multiply, sorry, just multiply with m2 and just multiply with m1 and just subtract, you will be get this type of equation. And just calculate. If you here you use the Newton's third law, that is the force on F21. This F21 can be written as minus of F12, and this can be written here, and take m1 m2 such that you can write here, and then divided m1 plus m2. So this is taken as mu is the mu1 plus mu2 by mu2. If this are the external force and this is the internal force, if there is no external force, then will be equal to that, right? So this will be like no external force, this 2 equal to 0. Yeah, the mu is the m1 m2 by m1 plus m2. This is known as the reduced mass. Why this is called reduced mass? Because this mass is this value is lower than both the m1 and m2. That's why it's called reduced mass. And you can see this expression is for a single particle. You can treat as the two particle as a single particle, right? They are I think clear. This is the equation of motion of two body problem. Now comes into the some problem. First you do yourself, otherwise we we can do further. Just take the screenshot and do yourself. This is question number 1. This is question number 2 and 3. Take the screenshot and do yourself. This is question number 4 and 5. Take the screenshot and do yourself, or you can pause the video and do yourself. This is question number 6. Okay, so try to do this problem. I think you can do that. If there is any problem, you must comment in the comment section. Okay, so we will meet in the next section. This is all about me, and this is my contact details, and this is my YouTube channel details. You can go through this channel, you can get the others video which already uploaded. Share this video to your friends so that he or she get benefit, and subscribe this channel to if you new in this channel, and press the bell icon to get the notification when I will uploaded the new video. Okay, so take care, we will meet in the next video as soon as possible. Thank you.